Can you see the slides?
Yes, ma'am.
Yes.
Yes,
Please, all of you mute yourself.
ma'am.
So today's topic is fatigue and recovery. We will discuss what is fatigue and what are the causes for fatigue and what are the best recovery modes in sports. So fatigue can be defined as an inability to maintain a given force or power output during repeated muscle contractions. When you are doing exercise, if you are unable to maintain the intensity of the exercise for longer period, then that is considered as fatigue. So obviously, when you start some exercise, initially you do with high intensity. As the time proceeds, after some time, your intensity will come down, right? Your power output will come down. That is considered as fatigue. So fatigue को generally हम कहते हैं जो एक्सरसाइज इंटेंसिटी चाहिए होता है, अगर उतना इंटेंसिटी को हम मेंटेन नहीं कर पाया तो उसको फैटिग या थकान कहा जाता है. ओके. Fatigue is of two types, central fatigue and peripheral fatigue. If the cause of fatigue is in the nervous system, if it is above the level of neuromuscular junction, then that fatigue is considered as central fatigue. If the decline in force, if the fatigue is due to the disturbances which occur above the level of neuromuscular junction, then it is considered as central fatigue. If the cause of fatigue is peripheral in region, मतलब after neuromuscular junction, neuromuscular junction के बाद कुछ गड़बड़ हो गया, उसकी वजह से fatigue हुआ, तो उसको हम कहते हैं peripheral fatigue. If you remember the nerve transmission, nerves will end near the neuromuscular junction. From there, the signals will transmit from nerve to muscle, then muscle contraction will occur. This area is considered as neuromuscular junction. If there is some problem above the neuromuscular junction, because of that fatigue is occurring, then it is considered as central fatigue. If there is a problem after the neuromuscular junction, because of that muscle force is decreasing, then it is considered as peripheral fatigue. So what are the causes of fatigue? Why this fatigue will occur? There are multiple factors which contributes to muscular fatigue, which includes fuel depletion, accumulation of waste products, neuromuscular events, and elevated body temperature and dehydration. Okay? बहुत कुछ फैक्टर्स के वजह से थकान हो सकता है. उसमें मेनली शामिल है फ्यूल की कमी के वजह से भी थकान हो सकता है. बाय प्रोडक्ट्स या एंड प्रोडक्ट्स ज्यादा अक्यूमुलेट होने के वजह से भी थकावट हो सकता है. न्यूरोमस्कुलर जंक्शन में या न्यूरोमस्कुलर सिस्टम में कुछ ऑल्ट्रेशंस हो गया, उसके वजह से भी थकावट हो सकता है. यानी कि एलिवेटेड बॉडी टेम्परेचर या डिहाइड्रेशन की वजह से भी थकान हो सकता है. Okay. So fuel depletion. What is fuel depletion and which fuel depletions are very common? When we consider fuel depletion, in last class we discussed about energy systems, right? When we were discussing about energy systems, I told that in our body ATP is very limited. ATP storage is very limited. Only 40 to 50 grams of ATP we can store in our entire body. वो 4 सेकंड के लिए काम करने के बाद उसका लेवल कम होना शुरू हो जाता है, राइट? तो इसको रीजनरेट करने के लिए वी हैव डिफरेंट फ्यूल्स. इफ वी आर डिपेंडिंग ऑन ATP CP सिस्टम, CP is the fuel. If you are relying on anaerobic glycolytic system, glucose or glycogen will act as a fuel. If you are relying on aerobic system, carbohydrate or fat will act as a fuel, right? Protein also can act as a fuel. So when we are telling about fuel depletion, you know the storage of glycogen, storage of CP are limited, right? CP का storage सीमित है. हमारा बॉडी में सिर्फ 120 ग्राम का क्रिएटिन फास्फेट रहता है बॉडी में. वो सिर्फ कुछ सेकंड के लिए, मे बी 10 सेकंड के लिए ATP को रिसिंथेसाइज करने में मदद कर सकता है, राइट? 10 सेकंड के बाद सीपी लेवल खत्म हो जाएगा, उसकी वजह से एटीपी सिंथेसिस भी रीसिंथेसिस भी कम हो जाएगा इससे, राइट। दूसरा फ्यूल है ग्लाइकोजन। ग्लाइकोजन का टोटल स्टोरेज होता है समवेयर अराउंड 500 ग्राम्स। ये भी कुछ मिनट काम करने के बाद, मे बी 60 मिनट्स के बाद या 120 मिनट्स मैक्सिमम काम करने के बाद इसका लेवल भी कम होना शुरू हो जाता है। उसकी वजह से ग्लाइकोजन से एटीपी सिंथेसिस भी कम हो जाएगा। So if you are doing moderate intensity activity, maybe 90 minutes या 120 minutes तक आप इस ग्लाइकोजन को यूज कर सकते हैं एटीपी को सिंथेसाइज करने के लिए। If you are doing very high intensity activity, ये खत्म होने से पहले ही लैक्टिक एसिड accumulation ज्यादा होने की वजह से fatigue हो सकता है, right? So here there are two reasons for fatigue when you are talking about glycogen. One is depletion of glycogen. If you are doing moderate activity for prolonged period, maybe after 90 minutes or 120 minutes, glycogen levels will come down. इसकी वजह से थकावट हो सकता है. If you are doing very high intensity activity, ग्लाइकोजन स्टोरेज कम नहीं होगा, लेकिन लैक्टिक एसिड अक्यूमुलेशन ज्यादा होने की वजह से भी फैटिग हो सकता है. So first cause for fatigue is fuel depletion. So when we are talking about fuel depletion, two fuel depletions are very common. One is ATP-CP depletion and the other one is glycogen depletion. We are not telling fat depletion because fat storage is unlimited in our body. We have very huge amount of energy which is stored as fat in our body, right? That much exercise or activity we won't be doing. If you remember, nearly 1 lakh calories we can store in the form of fat. So fat की deficiency कभी नहीं होगा, depletion कभी नहीं होगा, लेकिन glycogen depletion and ATP-CP depletion are common when the person is doing sports. So first one is ATP-CP depletion. ये कब हो सकता है ATP-CP depletion? When you are doing very high intensity activity, ATP-CP depletion is very common and it will be depleted within 10 seconds. Creatine phosphate levels will be depleted within 10 seconds when you are doing very high intensity activity. So as the phosphocreatine levels decreases, ATP synthesis also decreases. ATP synthesis also decreases. If you see this diagram, here you can see when you are doing activity, when you are doing exercise, ATP is converted to ADP. तो ATP को resynthesize करने के लिए creatine phosphate, here you can see, when you are doing activity, ATP levels are coming down. So ATP को resynthesize करने के लिए creatine phosphate is converted to creatine and this phosphate is donated to ADP to produce ATP. As your muscle is working, continuously ATP will be synthesized and it will be converted back to ADP. So after 10 seconds, this creatine phosphate levels will come down. So because of that, ATP resynthesis will be decreased. So what is the best way to regenerate creatine phosphate levels? Once creatine phosphate is depleted, how to regenerate it? क्या करना चाहिए इसको regenerate करने के लिए? Simply rest. Okay. No need to do anything. You have to take passive rest. When you stop your activity, when you decrease your intensity and when you completely stop your activity, automatically your body will have more ATP because ATP production will start from fat when you are in resting condition. Lots of ATP will be produced from fats through aerobic metabolism. Okay, and that ATP will be utilized to resynthesize creatine phosphate when you are in rest. But when you are doing exercise, creatine phosphate levels will come down. Okay. So when you are doing exercise, जब आप exercise करते हो उस time पे ATP use किया जाता है muscle contraction के लिए. इसके वजह से ATP level कम हो जाएगा. जब ATP level कम होगा, तब ADP को फिर से ATP के रूप में कन्वर्ट करने के लिए क्रिएटिन फॉस्फेट यूज होता है हमारा बॉडी में. क्रिएटिन फास्फेट इसका फास्फेट ग्रुप को एडीपी को डोनेट करके एटीपी को सिंथेसाइज करने में मदद करता है। ओके, ये इस प्रोसेस में थोड़ी देर में आफ्टर 8 सेकेंड्स क्रिएटिन फास्फेट लेवल्स कम हो जाएगा। इस क्रिएटिन फास्फेट को फिर से रीसिंथेसाइज करने के लिए एक तरीका है, वो है रिकवरी। Simply when you stop your activity, when you rest your body, automatically body में ATP level ज्यादा हो जाता है, क्योंकि रेस्टिंग कंडीशन में हमारा बॉडी में ATP प्रोडक्शन होता है फैट से, तो बहुत ज्यादा मात्रा में ATP प्रोड्यूस होता है थ्रू एरोबिक मैकेनिज्म, और ये ATP को यूज करके फिर से क्रिएटिन फास्फेट के रूप में कन्वर्ट हो जाए। So how much time you have to recover in order to resynthesize creatine phosphate? Creatine phosphate को resynthesize करने के लिए कितना मिनट रेस्ट लेना चाहिए? If you rest for 3 to 5 minutes, you can resynthesize 75% of creatine phosphate. 3 से 5 मिनट रेस्ट लेने से almost 75% of creatine phosphate will be resynthesized in our body. Okay. If you take more than this, you can see approximately 90% of it will be resynthesized. So recovery is the best way to resynthesize creatine phosphate levels in our body. So if you see any sprinters, sprinters who go for 100 meter, 200 meter sprints, they'll go for one sprint, and after finishing one sprint, they will take rest in between, right? एक sprint खत्म होने के बाद, they don't go for next sprint. They take 2-3 minutes gap, and then they go for next sprint. Why they take rest in between? Because when they go for first sprint, minimum sprint timing is 10 to 12 seconds, right? So when they go for first sprint, creatine phosphate levels will come down. And again, they take rest. They resynthesize the creatine phosphate levels, then they go for next sprint. They don't take rest, what happens? Their performance will be, their timings will be higher, right? And at the same time, you can see the creatine supplementation in case of sprinters. Most of the sprinters will be taking creatine supplementation. What for they will be taking creatine supplementation? When they take creatine supplementation, their body will have optimum amount of creatine phosphate. So if they can see the improvement of 1 second by taking supplementation, that also will be very valid for them, right? Valuable for them. So most of the sprinters will be taking creatine supplementation in order to improve the creatine phosphate levels and in order to strengthen ATP-CP system, okay? Then the second fuel depletion, which is commonly seen, is glycogen depletion. As you all know, in our body, very limited amount of glycogen is stored. Approximately 500 grams of glycogen is stored. Where the glycogen is stored in our body, can you put it in the chart box? Where glycogen is stored in our body? I can't see any answers.
Then muscle and liver.
Liver and muscle, both the organs can store glycogen in our body, and small amount is also present in brain tissue, okay? But mainly muscle and liver. See, when you compare these two, liver will have more capacity to store glycogen, okay? Liver is small, muscle is big in our body. Amount of muscle is more, but liver area is less in our body. So though it has more capacity, as the area is less, approximately 75 to 100 grams of glycogen is stored in liver. Approximately 400 grams of glycogen can be stored in muscles. So total, it is approximately 500 grams. Okay. And this is sufficient to produce approximately 2000 calories, which is almost equal to run about 20 miles. So this much energy we can store in the form of glycogen, which is sufficient to do this much activity. If you want to do more than this, if you want to continue your activity beyond this, then you may experience glycogen depletion. Or if you are doing very high intensity activity, then you can you have to stop the activity because of lactic acid accumulation. Okay, so glycogen depletion occurs during long-term activities that are done at moderate to medium to moderate intensity. Here, CP depletion is very common when you are doing high intensity activity. When you are putting 100% intensity, during those activities, CP depletion is common. But this glycogen depletion is common when you are doing medium to moderate intensity activity. Okay. So these are the different fuel sources for exercising muscle. So in our body, ATP storage limit is around 40 grams, and CP or phosphocreatine storage is approximately 120, and carbohydrate that is in the form of glycogen is around 500 grams, and fats, if you are a 75 kg, your weight is 75 kg, you can store approximately 15 kg of fats in our body. But if you see the rate of production of ATP synthesis, CP can produce ATP at very faster rate. It can produce 9 millimoles of ATP per kg per second. So production of ATP from CP system is very high, and then followed by lactic acid system or anaerobic glycolytic system, then followed by aerobic glycolytic system, and next by fats. So aerobic system is very slow in producing ATP, but whereas anaerobic systems are fast comparatively. Okay. And if you see the sources, these are the sources. This is the order. So first thing is, when you start your activity, your ATP will be used to your to do your muscular activity. जब पहले आप activity को शुरू करते हो, तो पहला आपका बॉडी में जो ATP है, मसल में जो ATP है, वो यूज किया जाता है. जब ATP का लेवल कम होना शुरू हो जाता है, तब ATP की रीसिंथेसिस शुरू हो जाता है क्रिएटिन फॉस्फेट से. So when your ATP levels start depleting, that time creatine phosphate will support ATP resynthesis. When your creatine phosphate levels start decreasing, when your creatine phosphate levels start declining, then your muscle glycogen, yeah, blood glucose will start producing ATP through lactic acid system. And when your glycogen levels are also depleting, then automatically your speed also will decrease. In that condition, fats will be supporting for the synthesis of ATP. This is how different fuel sources are used in your body. So what are the sources? First is direct ATP, then is creatine phosphate, then is glycogen, glucose, and then fatty acids. So second reason for fatigue is accumulation of metabolic byproducts or end products. When we are talking about end products, the main important end product is lactic acid. And there are other two end products. One is inorganic phosphate and the third one is ADP. Okay. Accumulation of inorganic phosphate and ADP also can lead to fatigue. So when we are talking about utilization of ATP, when ATP is used in our body, ATP will be converted to ADP, right? जब ATP यूज किया जाता है बॉडी में, वो ATP टूटने के बाद बनता है ADP, adenosine diphosphate, and inorganic phosphate, right? ATP breaks down to ADP and inorganic phosphate. So ADP has to convert it back to ATP again. If ADP levels are too high, then if inorganic phosphate levels are too high, this also can lead to fatigue. Okay. First, we'll discuss about lactic acid. Lactic acid हमारा बॉडी में कौन सा एनर्जी सिस्टम से उत्पन्न होता है? Which energy system will result in the formation of lactic acid? Put it in the chat box.
ATP-CP.
No.
Anaerobic.
Anaerobic.
Anaerobic glycolytic system. In anaerobic glycolytic system, glucose या glycogen will convert to pyruvic acid, then to lactic acid. याद आया है? Energy systems. See here, glucose or glycogen will be converted to pyruvic acid and then to lactic acid in the absence of oxygen. So this is anaerobic glycolytic system, यानी कि lactic acid system, right? Second energy system. So when you are doing high intensity activity, the amount of O2 supplied to your body may not be sufficient for your activity. जो oxygen supply हुआ है, अगर वो काफी नहीं है तो in that condition glycolysis anaerobic condition में होता है, then lactic acid is produced as end product. तो यहाँ lactic acid कहाँ उत्पन्न हो रहा है? मसल के अंदर, right? Lactic acid is produced right within your muscles. Usually क्या होता है? Lactic acid when it is produced in the muscles, slowly it will be released into your blood. मसल से उत्पन्न होने के बाद blood में release हो जाता है ये. ब्लड के द्वारा वो पहुंचेगा लिवर में. लिवर में लैक्टिक एसिड फिर से ग्लूकोज को बनाने में यूज किया जाता है, तो ग्लूकोज बन जाता है. अगेन फ्रॉम लैक्टिक एसिड पायरुविक एसिड विल बी फॉर्म, पायरुविक एसिड विल बी कन्वर्टेड टू ग्लूकोज. ओके, इस प्रोसेस को हम कहते हैं ग्लूकोनियोजेनेसिस. प्रोडक्शन ऑफ ग्लूकोज फ्रॉम नॉन कार्बोहाइड्रेट प्रिकर्सर इज कॉल्ड एज ग्लूकोनियोजेनेसिस. लिवर इज हैविंग yes.
लीवर में पहुंचने के बाद क्या बनता है?
लिवर पहुंचने के बाद ये फिर से ग्लूकोज के रूप में कन्वर्ट हो जाता है. लैक्टिक एसिड
ओके मैम,
फिर से ग्लूकोज को बनाने में यूज किया जाता है. ओके, एक बार लिवर में ग्लूकोज बनने के बाद फिर से ये ग्लूकोज ब्लड में रिलीज होगा और मसल्स या टिश्यूज को पहुंचेगा, फिर से टिश्यूज में यूज किया जाएगा. ओके, इट इज अ साइक्लिक प्रोसेस. पहले जो ग्लूकोज मसल के अंदर है वो लैक्टिक एसिड रूप में कन्वर्ट हो गया, फिर से ये लैक्टिक एसिड ब्लड में रिलीज होकर लिवर में पहुंचा, लिवर में फिर से ग्लूकोज के रूप में कन्वर्ट होके फिर से मसल में पहुंच रहा है. ओके, सो दिस साइक्लिक प्रोसेस को हम कहते हैं कोरी साइकिल. दिस साइक्लिक प्रोसेस इज कॉल्ड एज कोरी साइकिल. लेकिन अगर आपका एक्टिविटी बहुत ही हाई है, हाई इंटेंसिटी की है, तो तब क्या होगा? लैक्टिक एसिड प्रोडक्शन बहुत अधिक मात्रा में होता है. लैक्टिक एसिड विल बी प्रोड्यूस्ड इन लार्ज क्वांटिटीज एंड ये जो प्रोसेस है कन्वर्शन प्रोसेस, ये ठीक से नहीं होगा. व्हेन लैक्टिक एसिड अक्यूमुलेशन इज मोर, नो, उतना लैक्टिक एसिड को बॉडी अगर कन्वर्ट नहीं कर पाया तो ग्लूकोज के रूप में, इन दैट कंडीशन लैक्टिक एसिड लेवल्स विल इंक्रीज इन योर मसल्स. और लैक्टिक एसिड जब इंक्रीज हो जाता है तब ये
मैम सॉरी टू इंटरप्ट.
यस,
एक्सक्यूज मी मैम, क्या लैक्टिक एसिड ग्लूकोज में कन्वर्ट होता है मैम?
yeah, lactic acid will be again converted to glucose in liver.
But ma'am,
in liver, listen,
liver.
not in the muscle. muscle में वो जो enzymes चाहिए होता है वो नहीं रहता है. ओके, तो only liver can convert it to glucose.
मैम मैं थोड़ा सा कंफ्यूज हूँ इसमें, क्योंकि ग्लूकोज तो हमें कार्बोहाइड्रेट से मिलता है.
हाँ,
जो कार्बोहाइड्रेट है वो ग्लूकोज में कन्वर्ट होता है.
देखो
तो
एक्चुअली लिवर का एक कैपेसिटी होता है. लिसन जितेंद्र, लिवर इज हैविंग,
आई थिंक लीवर जो है वो लैक्टिक एसिड को रिमूव करता है थ्रू ब्लड फ्रॉम मसल्स.
नहीं, एक्चुअली लैक्टिक एसिड जो मसल में प्रोड्यूस हो रहा है वो रिलीज हो जाएगा ब्लड में. ब्लड में रिलीज होने के बाद वो शरीर से बाहर नहीं जाएगा. कभी देखा है लैक्टिक एसिड एक्सक्रीट हुआ है करके? कभी सुना है?
नहीं मैम, लैक्टिक एसिड जो है वो बॉडी में से थ्रू जो वेस्ट मटेरियल्स होते हैं, आई थिंक
वो सुना है
वहां से
कभी
निकलता है.
लैक्टिक एसिड एक्सक्रीट हो जाता है बॉडी से करके?
वो किसी और फॉर्म के अंदर रिलीज होता है मैम, वो मुझे थोड़ा अभी कंफर्म नहीं है। चलो
नहीं,
कोई बात नहीं मैम, जो आप कह रहे हैं शायद सही होगा।
ओके, यू बेटर
हाँ
रीड
जी।
इट वंस अगेन, ये जो मैं बता
ओके
रही
मैम।
हूँ। ओके, लिवर का एक
ओके।
कैपेसिटी होता है ग्लूकोज लेवल्स को ये मेंटेन करता है। ये एक्चुअली जब ग्लूकोज लेवल कम है हमारा बॉडी में, अगर ब्लड में ग्लूकोज लेवल कम हो गया तो लिवर कैन प्रोड्यूस ग्लूकोज फ्रॉम नॉन कार्बोहाइड्रेट प्रिकर्सर्स। जो नॉन कार्बोहाइड्रेट प्रिकर्सर्स है उससे ग्लूकोज को बना सकता है। ओके, उस प्रोसेस को हम कहते हैं ग्लूकोनियोजेनेसिस। ये भी एक ऐसा प्रोडक्ट है, लैक्टिक एसिड जो है ये नॉन कार्बोहाइड्रेट प्रोडक्ट है, ये कार्बोहाइड्रेट के रूप में कन्वर्ट किया जाता है। ओके, सो इट इज कन्वर्टेड टू ग्लूकोज, इट इज ए बाई प्रोडक्ट। यहाँ मजल में एंड प्रोडक्ट है, ये मजल में इसका कोई रोल नहीं है। ओके, बट लेकिन मजल से बाहर निकलने के बाद it can be converted to glucose in the liver. See, I am talking about fast twitch fibers, not about slow twitch fibers. Okay, मसल में भी दो तरीके का मसल फाइबर होता है, फास्ट ट्विच एंड स्लो ट्विच। फास्ट ट्विच फाइबर्स और स्लो ट्विच फाइबर्स में डिफरेंस क्या होता है? Slow twitch fibers produce more of energy through aerobic mechanism, right? Most of the energy is produced through aerobic mechanism. Fast twitch fibers में most of the energy is produced through anaerobic mechanism. So when you are doing high intensity activity, fast twitch fibers are recruited more. मसल्स में जो फास्ट ट्विच फाइबर्स होता है उसका रिक्रूटमेंट ज्यादा होता है, तो उस फाइबर्स में ग्लाइकोजन लैक्टिक एसिड रूप में कन्वर्ट हो जाता है। ओके, इफ यू आर टॉकिंग अबाउट slow twitch fibers, mostly slow twitch fibers convert glycogen to pyruvic acid, not lactic acid. Only fast twitch fibers converts glycogen to lactic acid. Okay, when lactic acid is more, it will be released into the blood and then taken up by the liver. Liver will convert it back to glucose and again that glucose will be released into your blood. एक बार ब्लड में आने के बाद ये ग्लूकोज ब्रेन के लिए भी सप्लाई हो सकता है या मसल के लिए भी सप्लाई हो सकता है या कुछ और टिश्यू के लिए भी सप्लाई हो सकता है। बट इफ यू इमेजिन देयर इज a cyclic imagination, right? Glucose is converted to lactic acid in the muscle, then released into the blood, then lactic acid is converted back to glucose in the liver, again that is released into the blood and supplied back to muscle to continue the activity. इस साइक्लिक प्रोसेस को हम कहते हैं कोरी साइकिल। ओके, सपोज लैक्टिक एसिड ठीक से रिमूवल नहीं हुआ, मसल से रिमूवल नहीं हुआ, लैक्टिक एसिड का अक्यूमुलेशन हो गया मसल में, लैक्टिक एसिड की स्तर बढ़ गया मसल में, तब क्या हो सकता है? whenever the lactic acid levels are high, lactic acid matlab it will have a group called COOH group. It will have a functional group called COOH group. Okay, so when lactic acid levels are high, this group will convert to COO minus and H plus ions. This will dissociate into COO minus and H plus ions, hydrogen ions. Okay, so when lactic acid levels are high, hydrogen ions, more hydrogen ions will be released into the blood. Hydrogen ion concentration increases. When the hydrogen ion concentration increases, blood की pH जो होता है, blood में जो hydrogen ion की concentration pH होता है वो कम हो जाता है। अगर ये बढ़ गया तो हाइड्रोजन आयन की गाढ़ता बढ़ गया तो pH कम हो जाता है। अगर pH कम हो गया तो most of the enzymes won't work properly. जो enzymes energy production के लिए important होता है वो ठीक से काम नहीं करेगा। So energy तो जरूर है muscle contraction होने के लिए. We need to have ATP to do muscle contraction. अगर pH में कुछ चेंज आया तो एंजाइम्स ठीक से काम नहीं करेगा, तो ATP नहीं बनेगा ठीक से, इसके वजह से फैटिग होने का चांसेस है। ओके, so the more lactic acid accumulated, the more hydrogen ions. When hydrogen ion concentration is more, that results in the decrease in blood pH. And these hydrogen ions also interfere with calcium release from sarcoplasmic reticulum. Muscle contraction होने के लिए calcium बहुत ही important है। अगर कैल्शियम ठीक से रिलीज नहीं हुआ तो मसल कंट्रैक्शन नहीं हो सकता। इफ यू रिमेंबर कंट्रैक्शन कपलिंग थियरी, स्लाइडिंग फिलामेंट थियरी पता है ना आप लोगों को? एक्टिन मायोसिन हेड्स कैसा इंटरैक्ट करता है, एटीपी कैसा यूज किया जाता है, कैल्शियम कैसा रिलीज होता है, ट्रोपोनिन कैसे, डू यू नो ऑल दिस थिंग्स, मसल कंट्रैक्शन?
Yes, ma'am. Sliding filament theory.
यस यस यस, स्लाइडिंग फिलामेंट थियरी के लिए एटीपी इज वेरी इंपॉर्टेंट, राइट? स्लाइडिंग होने के लिए एटीपी इंपॉर्टेंट, एंड कंट्रैक्शन कपलिंग के बारे में भी सुना होगा, कैल्शियम रिलीज इज वेरी वेरी इंपॉर्टेंट. सो इफ कैल्शियम रिलीज इज हैम्पर्ड, इफ कैल्शियम रिलीज ठीक से नहीं हुआ पीएच चेंज होने की वजह से या हाइड्रोजन आयंस की वजह से, उसकी वजह से मसल कंट्रैक्शन भी ठीक से नहीं होगा. So this is how lactic acid will result in muscle fatigue. Actually, everybody will think lactic acid leads to fatigue, but lactic acid की वजह से नहीं होता है. lactic acid से जो हाइड्रोजन आयंस रिलीज होता है उसके वजह से जो pH में चेंजेस होता है उसके वजह से fatigue होता है एक्सरसाइज के बाद, हाई इंटेंसिटी एक्सरसाइज के बाद. Apart from that, accumulation of inorganic phosphate or increased adenosine diphosphate also can lead to मसल फैटिग. ये दोनों ज्यादा होने की वजह से भी फैटिग हो सकता है. दिस इज द साइकिल व्हिच आई मेंशन्ड अबाउट, कोरी साइकिल. See in muscle what is happening, glycogen is converted to lactate, then this lactate is converted back to glucose in the liver and again supplied back to muscle. This cyclic process is called as Cori cycle. Then let's talk about lactate threshold. कभी सुना है lactate threshold के बारे में? What is your understanding about lactate threshold?
मैम जब लैक्टिक एसिड बढ़ जाता है तो उसको, और हम उसको कंट्रोल कर पाते हैं तो उसे लैक्टिक थ्रेशोल्ड हो.
Okay, let me explain. See,
Ma'am,
from this
when it started depleting, the lactate start depleting, the formation got stopped.
stops or starts?
Yes, ma'am, exactly. Start. Sorry.
Start.
Okay, okay. Let me explain. If you see this graph, what you can see here is the lactate level, right? On x-axis, they have given running speed. On y-axis, they have given lactate levels, right? So as the speed is increasing, here there are two people. One is untrained person. Blue dots represents untrained person and red dots indicate trained person. Okay. So untrained person, matlab before training, as the speed is increasing, see this here at this point of time, here he is at the speed of 4 km/h. His lactate was 2 millimole per liter. When the speed increased to 5.5 km/h, lactate is still on 2. Okay. And the speed progressively increased. And when he reached 10 km/h speed, his lactate started increasing, right? When he was at the speed of 11.8 km, his lactate started increasing. His lactate crossed beyond 2 millimole per liter, right? So what is lactate threshold? The exercise intensity at which there is an abrupt change in lactic acid levels. कौन सा इंटेंसिटी में लैक्टिक एसिड लेवल्स बढ़ना शुरू हो जाता है, लैक्टिक एसिड के लेवल इंक्रीज होना शुरू हो जाता है, उस इंटेंसिटी को हम कहते हैं लैक्टेट थ्रेशोल्ड. इसको टेस्ट करके क्या फायदा हम ले सकता है, स्पोर्ट्स पर्सन के लिए ये टेस्टिंग करने से क्या मदद हम दे सकता है? When you know the lactate threshold, you can change your training protocols accordingly. Suppose, see this person, before training, his lactate threshold was somewhere at this speed, 11.8 km. But after training, his lactate threshold was somewhere at this speed, 13 km. So पहले इसका lactic acid level 11.8 km में बढ़ जाता था, लेकिन ट्रेनिंग लेने के बाद इसका लैक्टिक एसिड बढ़ेगा सिर्फ ओनली व्हेन ही इज रनिंग विद द स्पीड ऑफ 13 km/h, राइट? तो ये ट्रेनिंग देने से क्या फायदा मिला है? ज्यादा हाई इंटेंसिटी ट्रेनिंग, हाई इंटेंसिटी एक्सरसाइज ये कर पा रहा है विदाउट चेंजिंग द लैक्टिक एसिड लेवल, राइट? वी कैन give a specific training accordingly. Suppose if your lactic acid levels are increasing at the speed of 11 kilometer, you have to take the training with the same speed for next few months. Then your body will adjust to that speed. Then when you test your lactic acid levels again, you can see some improvements in your lactate threshold. So you can do high intensity activity without changing your lactic acid level. Means you are doing high intensity activity without developing fatigue, right? Your lactic acid is not increasing, means your fatigue, your chances of getting fatigue are less now. So this is how we can make use of this testing for the betterment of athletes. So what do you mean by lactate threshold? The exercise intensity at which there is an abrupt increase in blood lactate concentration is called as lactate threshold. So lactate threshold can be improved with the training. Clear? Third reason for fatigue is neuromuscular events. So when you are doing activity, your nerves will be continuously giving signals to your muscles. So when the signal reaches the nerve ending, there is a release of neurotransmitter. Then there is changes in sodium and potassium ion concentrations here, right? So after some time, when you are doing continuous activity, maybe after half an hour, maybe after 1 hour, your neurotransmitter levels will decrease here. Your muscle is getting the signal, sorry, your nerve is getting the signal transmission, but in order to give the same signal to the muscle, it has to release a chemical, right? लेकिन continuously जब आप exercise करते हो, तब अगर वो जो केमिकल चाहिए होता है सिग्नल को देने के लिए, सिग्नल ट्रांसफर करने के लिए, अगर वो केमिकल खत्म हो गया, वो जो न्यूरोट्रांसमीटर चाहिए होता है, अगर उसका प्रोडक्शन कम हो गया, उसकी वजह से भी फैटिग हो सकता है. So accumulation of some of the neurotransmitters or depletion of some of the neurotransmitters can lead to fatigue. And altered sodium potassium gradient also can lead to fatigue. If you know the membrane structure, membrane physiology, most of the membranes will have more of potassium inside. Cells will have more of potassium inside and more sodium ions outside. All the sodium ions are outside the cell and all the potassium ions are packed inside the cells. When you are doing activity, when the nerve impulse reaches, most of the sodium will enter the cell and potassium will leave the cell. So here the gradient is disturbed. All the sodium ions entered inside, potassium ions have gone outside. Then you have to take rest in order to adjust this back to the normal state. When you are doing activity, so potassium has gone out, sodium has reached inside the cell. You need to give rest in order to send back the sodium out and to bring back the potassium in. Okay. If you don't give that rest in between, then also fatigue can occur due to altered sodium potassium gradient.
Excuse me.
शैलेंद्र,
मैम ये दोनों लास्ट स्लाइड एक बार हिंदी में थोड़ा बता दो ना प्लीज.
See, third cause for fatigue is, first cause क्या है? Fuel depletion. Fuel depletion होने के वजह से fatigue हो सकता है. Second reason ये है accumulation of end products. End products या by products accumulation ज्यादा होने के वजह से भी fatigue हो सकता है. Third reason for fatigue is neuromuscular events. Nerves और muscles के बीच में कुछ गड़बड़ हो गया, तो उसकी वजह से भी fatigue हो सकता है. तो क्या प्रॉब्लम हो सकता है nerves में और muscles में? क्या प्रॉब्लम होने की वजह से फैटिग हो सकता है, ये मैं एक्सप्लेन कर रही हूँ अभी. सी व्हेन यू आर डूइंग एक्टिविटी, सो सपोज आप कौन सा आर यू फ्रॉम स्पोर्ट्स बैकग्राउंड शैलेंद्र?
जस्ट मैम
एथलेटिक. ओके. सपोज यू गो फॉर लॉन्ग डिस्टेंस रन. ओके. आफ्टर सम टाइम यू फील आई कांट रन एनीमोर, यू हैव टू स्टॉप योर एक्टिविटी. तो क्या प्रॉब्लम हो सकता है? व्हेन यू आर डूइंग कंटिन्यूअस रनिंग, ये जो न्यूरोमस्कुलर जंक्शन है, इधर सिग्नल ट्रांसमिशन ठीक से नहीं होगा. ओके. सो फर्स्ट थिंग, योर ब्रेन हैज टू सेंड सम सिग्नल्स, राइट? योर ब्रेन विल सेंड द सिग्नल्स. दो सिग्नल्स विल बी कैरीड बाय योर nerves. Nerve will reach on your muscle and near the neuromuscular junction, there is release of acetylcholine, other neurotransmitter, right? When the information reaches the nerve endings, acetylcholine has to be released. Then only muscle contraction will start. If this chemical is not released, signal won't be communicated from nerve to muscle. Okay. Suppose if you are doing continuous activity, maybe after some time this chemical will be depleted. जो chemical चाहिए है वो ट्रांसमिशन को, सिग्नल को ट्रांसफर करने के लिए, अगर वो केमिकल खत्म हो गया तो सिग्नल ठीक से कम्युनिकेट नहीं हो पाएगा नर्व और मसल के बीच में, उसकी वजह से भी फेटिग हो सकता है. समझ हुआ? Did you understand, Shailendra?
Thank you, ma'am.
And then second is altered sodium potassium gradient. See, in our cells, हमारा cells में सेल के अंदर पोटेशियम आयन कंसंट्रेशन ज्यादा मात्रा में रहता है, सेल के बाहर सोडियम आयन कंसंट्रेशन ज्यादा रहता है. ओके. लेकिन जब मसल कंट्रैक्शन होता है तब पूरा पोटेशियम आयन बाहर चला जाएगा और सोडियम आयन अंदर आ जाएगा. ओके. इन दिस कंडीशन यू हैव टू प्रोवाइड रेस्ट टू योर बॉडी. अगर रेस्ट प्रोवाइड किया तो बॉडी क्या करेगा, फिर से वो जो पोटेशियम बाहर गया है उसको अंदर लेके आएगा. देखो, पोटेशियम इज कमिंग इनसाइड एंड जो सोडियम अंदर आ गया है उसको बाहर भेजेगा. सो ये रिवर्स हो जाएगा रेस्ट देने से. अगर रेस्ट नहीं दिया तो ये बिगड़ा हुआ सोडियम पोटेशियम ग्रेडियंट की वजह से फेटिग हो सकता है. ओके, क्लियर?
Thank you, ma'am. जी मैम.
The last reason for fatigue is elevated body temperature and dehydration. Body temperature, body तापमान ज्यादा होने की वजह से और dehydration ज्यादा होने की वजह से भी fatigue हो सकता है. So why this dehydration will occur? Why the body temperature increases first of all when you are doing activity? See, I said you need energy to do work, right? So energy can be converted from one form to another form. Energy cannot be destroyed, right? Energy cannot be created and nor cannot be destroyed. Energy will transfer from one form to another form. When you are doing activity, when you are doing exercise in your body, chemical energy which is stored in your carbohydrates, proteins, fats or ATP is converted to mechanical energy. Your body will convert chemical energy into mechanical energy, energy which is used by the muscles. Okay. During this process, some amount of heat, some amount of energy is released as heat. When this conversion is taking place, when the chemical energy is converted to mechanical energy, some amount of energy is released as heat. So because of this, your body temperature increases. When you are doing exercise, you can feel it, right? Your body temperature increases. Exercise के दौरान body का तापमान, core temperature जो होता है वो बढ़ जाता है, क्योंकि जब आप काम करते हो, जब आप एक्सरसाइज करते हो, उस टाइम थोड़ा सा एनर्जी हीट के रूप में बाहर निकल जाता है, उसके वजह से बॉडी के टेम्परेचर बढ़ जाती है. इस टेम्परेचर को कम लेके आने के लिए, कम करवाने के लिए बॉडी विल स्टार्ट स्वेटिंग. ओके, स्वेटिंग विल अकर in order to reduce your body temperature. Your body will have a very good procedure to maintain your body temperature. Always our temperature is maintained at around 37 degrees centigrade, right? When you are in hot climate also it will be maintained. When you are in cold climate also it will be maintained constantly. So your hypothalamus will work on it. So when your body temperature increases, automatically to reduce the body temperature, blood circulation to your periphery will increase. More blood will be supplied through your skin. During this process, some amount of heat will be eliminated into the environment. So your body temperature will again decrease. During this process, you will lose some amount of water in the form of sweat. In order to reduce body temperature, you are losing water in the form of sweat. And here, one good thing is your body temperature is maintained. And the other bad thing is you are losing your body water, that is leading to dehydration. And you are also losing some of the electrolytes from your body. When you are sweating, you are losing sodium also, potassium also, along with the water, right? So that is a drawback. So what is dehydration? If your intake is not matching with the output, if your intake is not sufficient, water intake is less, water excretion is more, that leads to dehydration. And 3% dehydration, if you are losing your 3% of your body weight in the form of sweat, that will decrease your performance very badly. So dehydration is directly linked with the performance. So it is very important to refuel your body and to add fluids to your body when you are doing exercise. Two things you have to remember: when you are doing exercise, your fuel count will come down, your fuels will come down. You have to refuel your body, add glucose, add food immediately after exercise. That is refueling. At the same time, when you are doing exercise, your sweat rates are more, you are losing water from the body. To compensate that, you have to provide fluids to your body. So during event, it is very important to consume water. If your event is long duration event, and if your sweat rates are high, and if you are playing at hot environment. Okay. So what are the common causes of fatigue when you are relying on different energy systems? Suppose you are doing very high intensity activity, matlab you are relying on ATP-CP system. In that condition, what are the common causes of fatigue? When you are relying on ATP-CP system, main cause of fatigue is CP depletion and muscle ATP depletion and accumulation of inorganic phosphate. These three are the common causes of fatigue when you are doing very high intensity activity by using ATP-CP system. So how to reverse this? CP depletion, how to reverse this? You stop doing activity, take enough rest, automatically it will be reversed. Few minutes of rest after each sprint or after each high intensity activity. Suppose if you are using lactic acid system, you are doing moderate intensity activity and lactic acid is the main energy system for your activity. In that case, what are the common causes of fatigue? Accumulation of lactic acid, decreased blood pH are the common causes of fatigue when the person is relying more on lactic acid system. Yours is an aerobic activity. You are going for marathon run where the maximum energy production is from aerobic activity. In that condition, what could be the cause of fatigue? When you are doing aerobic, you are doing for longer period. Your duration is long, so all your fuels will come down. See, first glucose levels may go down in the blood. That is called as hypoglycemia. In blood, if glucose levels decreases, that condition is called as hypoglycemia. And then muscle glycogen also decreases when you are doing long duration activity. Based on your glycogen content, maybe after 60 minutes, 90 minutes, 120 minutes, your glycogen levels will come down. Okay. So to avoid this, you have to add more carbohydrate rich food before the competition. Now you might have heard about carbohydrate loading, glycogen loading. So before competition, when you have competition, maybe 3 days before the competition, you will start consuming more of carbohydrate rich food. When you eat this carbohydrate rich food, your muscle glycogen content will be maintained for longer duration. So you can continue your activity without glycogen depletion for longer period. Hope you are understanding.
Yes, ma'am.
Okay. When जब आप aerobic activity करते हो, उस time क्या-क्या reasons के वजह से थकान हो सकता है, वो explain कर रही हूँ मैं. अगर आप लंबा एक्टिविटी कर रहे हैं तो हाइपोग्लाइसीमिया हो सकता है, मतलब ब्लड में ग्लूकोज के लेवल्स कम होने की वजह से भी फेटिक हो सकता है, यानी कि मसल में ग्लाइकोजन कंटेंट कम होने की वजह से भी फेटिक हो सकता है. तो इन दोनों को कैसे प्रिवेंट करें हम? हाइपोग्लाइसीमिया को कैसे प्रिवेंट करना है? एनर्जी ड्रिंक्स लेने से. मैराथन रनर्स बीच बीच में पानी लेते हैं, पानी में थोड़ा ग्लूकोज या एनर्जी ड्रिंक लेते हैं, राइट? तो वो लेने से क्या होगा, ब्लड में ग्लूकोज लेवल्स जल्दी खत्म नहीं होता है, कम नहीं होता है. तो आप और थोड़ी देर के लिए विदाउट फेटिक आप परफॉर्मेंस कर सकते हैं. मसल ग्लाइकोजन लेवल्स को कैसे मेंटेन करना है? एक्सरसाइज के बीच में स्पोर्ट्स ड्रिंक लेने से भी मसल ग्लाइकोजन थोड़ा मेंटेन होगा, लेकिन मसल ग्लाइकोजन को अच्छी तरह मेंटेन करने के लिए एक रास्ता है, वो है ग्लाइकोजन लोडिंग या कार्बोहाइड्रेट लोडिंग। ये कैसा करना है? एक्सरसाइज के पहले 3 दिन पहले हाई कार्बोहाइड्रेट डाइट लेने से मसल में ऑप्टिमम मात्रा में ग्लाइकोजन स्टोर होता, और इसके वजह से आप थोड़ा लॉन्गर पीरियड विदाउट फैटिग आप एक्टिविटी को कंटिन्यू कर सकते हैं। ओके, नेक्स्ट रीजन फॉर फैटिग व्हेन यू आर डूइंग एरोबिक एक्टिविटीज, डिहाइड्रेशन। डिहाइड्रेशन होने की वजह से फैटिग हो सकता है, हाइपरथर्मिया होने की वजह से फैटिग हो सकता है। इसको कैसे प्रिवेंट करें? टेक वाटर इन बिटवीन व्हेन यू आर रनिंग, व्हेन you have to sip some amount of water.
Ma'am, I have a question.
Yes.
Ma'am, I belong to a combat game, and you just said that 3 days पहले ये जो आपने कार्बोहाइड्रेट लोडिंग बोला है, but we have a weight issue in our game. So how it could be possible?
Listen, one thing, you are telling combat sport, okay? Duration कितना है? Within 10 minutes, right? और वो भी 2 मिनट एक्टिविटी होगा, 1 मिनट रिकवरी होगा, 2 मिनट एक्टिविटी 1 मिनट रिकवरी, ऐसा होता है, राइट? हाँ, so it is not falling under aerobic. It is not falling under aerobic. It is anaerobic.
Ma'am, it may be a longer duration भी हो जाता है, कई बार
होता है, लेकिन
कई बार
that's what I am telling about. Glycogen loading is mainly for endurance sports. Okay. What you said is really correct, Taruna. ग्लाइकोजन लोडिंग करने के टाइम पे वेट का भी ध्यान में रखना है, क्योंकि हर एक मॉलिक्यूल ऑफ ग्लाइकोजन के साथ 3 मॉलिक्यूल ऑफ वाटर अक्यूमुलेट हो जाता है। 1 ग्राम ग्लाइकोजन स्टोर हुआ तो उसके साथ साथ 3 ग्राम पानी भी अक्यूमुलेट हो जाता है। मतलब आप 100 ग्राम ग्लाइकोजन को स्टोर करने के चक्कर में और 300 ग्राम पानी भी स्टोर हो जाता है। मतलब फुल वेट विल बी अराउंड 400 ग्राम, ऑलमोस्ट आधा केजी हो गया, राइट? सो आपका इवेंट के हिसाब से कौन सा इवेंट है, कितना है ड्यूरेशन, कौन सा एनर्जी सिस्टम यूज होने वाला है, ये ग्लाइकोजन लोडिंग चाहिए या नहीं चाहिए, या क्रिएटिन सप्लीमेंटेशन आपका गेम के लिए चाहिए या नहीं चाहिए, ये सब देख के करना पड़ता है, साइंटिफिकली करना है। आप एक स्प्रिंटर क्रिएटिन सप्लीमेंटेशन ले रहा है करके एंड्योरेंस रनर्स क्रिएटिन सप्लीमेंट लेने से कुछ फायदा मिलेगा या नहीं? नहीं मिलेगा, राइट? Creatine is important for sprinter, right? Glycogen loading is important for endurance runner. तो आपका गेम के हिसाब से जो करना चाहिए साइंटिफिकली वो करने से आपको मैक्सिमम बेनिफिट मिल जाए। ओके?
Can we use this carbo loading for squash and tennis players?
Tennis player.
Yes, ma'am. Squash and tennis players.
See, any sport, you have to, the research says like the duration. Suppose if you are relying on more on muscle glycogen, when before competition, if you are taking good amount of carbohydrate rich diet, that is definitely going to improve your glycogen levels and to improve your energy production from the glycogen. Okay. Hello. Ramlingam, is it clear? Tennis, when you are talking, where the duration is not fixed, you have to maintain energy levels for longer period. So you should concentrate like which is the best fuel for your body. That you have to consider based on the opponents and time duration, and definitely you can get the benefit out of it. Okay. So apart from this, decreased glucose and glycogen levels, dehydration, hyperthermia, and loss of electrolytes also can lead to fatigue. So taking water in between, again, when I'm telling taking water or taking food only for few games where the duration is too long. If the duration is more than 60 minutes, then if it is more than 15-30 minutes, then only you have to drink water in between. There is no point in drinking water for event which is going to finish within few minutes. Okay. Then we'll talk about recovery. Now you have some idea about fatigue, what are the causes of fatigue, how to prevent fatigue. Then we will see about recovery. What is recovery? Recovery is nothing but bringing back your body to the normal condition. Recovery aims to return your body to pre-exercise condition. When you are doing exercise, your energy levels will come down, your fluid levels will come down, your waste products will increase, right? Energy levels decreases, fluid decreases, and waste product accumulation increases. So you have to reverse all these. Energy levels decrease due to fuel depletion, so refuel it. Add fuel to your body. Your fluid levels decreased, so add water to your body. Add fluid to your body. And your waste products increased. You have to eliminate waste from your body. By doing so, you can reverse the condition of your body. So how to do? What are the modes of recovery? The modes of recovery include nutrition, refueling and rehydration, then rest, then hydrotherapy, sports massage, and so on. Okay. So first we'll discuss about rest. Rest can be of two types. One is passive rest and other one is active rest. What do you mean by passive rest? Passive rest means you just stop your activity. After event, you stop your activity completely, just sit or lie down. This is called passive recovery. Passive recovery would help to resynthesize your ATP-CP, okay? It will help to resynthesize your creatine phosphate levels, but it is not going to help you with the removal of lactic acid. Passive recovery will benefit to resynthesize ATP-CP, but if you are relying on lactic acid system, if your lactic acid levels are more, you can't remove your lactic acid levels by doing passive recovery. Then the second type of recovery is active recovery. In this, what do you do? After finishing the activity, don't stop your activity. You bring down your intensity and continue your activity for 5 to 10 minutes with the low intensity. Then you stop the activity. This is called active recovery. Active recovery is very much important to remove the lactic acid from our body. It will be helpful to remove lactic acid. It increases the supply of blood and nutrients to your tissues. How it will improve? It will prevent the venous pooling. When you are doing activity, your circulation will increase, your venous pooling will decrease. So when the blood is passing through your muscles, when the blood is rushing through your muscles, all the lactic acid which is accumulated in your muscle will be washed off. Okay. So in this way, it will help you to remove the lactic acid accumulation from the muscles. It will take out all the lactic acid from muscle. Then again, it will supply that lactic acid to the liver for its conversion. So active recovery is very much important for the people who are relying on lactic acid system to remove the lactic acid. Then the second mode of recovery is nutrition. Nutrition is very important. You have to concentrate on refueling and rehydration. So within half an hour, when the activity is finished, any sports person, whether it is a competition or normal training, within half an hour after the training or after the competition, they have to provide nutrients to the body in the ratio of 4:1. Carbohydrate and protein ratio should be 4:1. Okay, in this ratio, they have to provide. Either it could be a small banana or any kind of snack. It is very important to provide within 30 minutes after the activity. This also decreases the cortisol level. This also decreases stress level. It helps to maintain blood glucose levels. It helps to maintain glycogen levels, etc. Okay. And when you are talking about nutrition, you should also drink water. If your event is long duration event, every 15 minutes, you have to consume 150 to 250 ml of water. If possible, you have to take cold water because cold water absorption will be more, and you can add little glucose and salt to it, because when you are adding glucose, it will maintain your blood glucose levels also. And when you are adding small amount of salt, that will help you to maintain your electrolyte levels. जो electrolytes sweat के रूप में बाहर जा रहा है, उसको maintain करने के लिए help होता है. Okay, don't add too much sugar. Okay, there is a limit to add sugar or glucose to water. When you are adding, it should not exceed more than 6 grams per 100 ml. Okay, if you are adding glucose also, it should be between somewhere 4 to 8, or we can say approximately 6 grams per 100 ml. Only that much glucose or sugar need to be added. And if you can take protein shakes or branched chain amino acids or antioxidants after the event, that will help you to recover also faster. Because when you are doing activity, your muscle protein tear will happen. Muscle proteins may get teared. Okay, those torn proteins has to be recovered, repaired. So for that repair process, it is important to provide protein as well as branched chain amino acids. Branched chain amino acids will have anabolic effect. They promote the muscle growth also, and they are also important to fuel your muscles. They provide fuel also to your muscles. Then the next mode of recovery is hydrotherapies. Hydrotherapies are of different types: cold water immersions, hot water immersions, contrast water therapies you can go for. Cold water immersion means usually the area will be immersed, like legs will be immersed into the water, which is at the temperature of 15 degrees, maybe for 10 minutes. Cold water immersion will help you to decrease the inflammation. It will decrease your core body temperature also, and it will help you to decrease the inflammation in your body. Then hot water immersion means immersing body parts into the water, which is of around 40 degrees centigrade. This will help to increase the blood supply and range of motion. Hot water immersion would be helpful to increase the blood circulation and to increase the range of motion. It decreases the pain. Okay. And contrast water therapy. Contrast water therapy, what do you do? First, initially, you will take cold water immersion, then again hot water immersion, again cold water, again hot water. In contrast, you will be doing one after one. Okay. How it will be helpful? When you are in cold water immersion, vasoconstriction will take place. Blood vessels will constrict. When you are in hot water immersion, vasodilatation will take place. Blood vessels will dilate. Okay. So alternate vasoconstriction and vasodilatation will take place when you are undergoing contrast therapy, contrast water therapy. This increases the blood flow to your body parts and increases the recovery. It also washes out your lactic acid levels and all. Next mode of recovery is massage. Sports massage will be helpful to reduce the pain, inflammation, to boost the recovery from an injury. It also promotes blood circulation, increases the mobility and flexibility, and improves the sleep, and it also gives psychological soothing effect with the relaxation. So these are the benefits of sports massage. So ultimately, winning formula is train hard and recover well. Both the things need to be balanced. Training and recovery should happen well in balance. Then only we can see enhanced performance. Any doubts?
मैम पहले की स्लाइड्स एक बार फिर दिखा दीजिए.
Which one? Very first one?
जी मैम.
Is this?
जी मैम. मैम सेकंड स्लाइड प्लीज. Next slide.
If you want slide, I will share, not an issue. All the slides will be shared. No worry. Okay.
Yes, ma'am. Thank you, ma'am.
Okay. Any other doubt?
Ma'am, in practice session, taking more cold water, taking the students good or bad?
It should not be. It should not be too cold also. Okay. You should not take too much cold, chilled water. It should not be taken. It should be mild, like normal.
What is the side, ma'am? If it is taking the more cold water, what is the side effect? Any organs or anything affected or?
See, it's not about side effect or this thing. Only absorption point of view we are thinking about. Okay. So if they take mild cold water, that absorption rate would be faster. Okay. It will be absorbed quickly. So why we are taking water? In order to replenish your losses, and that will happen immediately. Okay, and
because
they say
some
you should not.
Summer season, students are like more cold water in between the session, so that's only I'm asking that question.
More cold water is not suggestible, because again absorption rate would be less, and so that may cause some kind of inconvenience in the stomach also. Okay. You have to explain them. This is the way to take. Then they,
okay, ma'am. Okay.
And again, the sipping and gulping. Okay, they should not gulp the water. They have to sip it. So when they're gulping, again, air also will go inside, right? Slowly they have to sip.
Okay, ma'am. Okay, thank you.
Ma'am, I want to know in combat sports we used to play from our weight categories. So sometimes we have to cut down our weights. So I just want to know what are the things we should take care when we are cutting down our weights.
Weight reduction should not happen during the competition. That is what we say. If you are planning for weight reduction, you have to plan it when you are in off season. So most of the combat people, what they do, they will stop eating just before the competition to reduce their body weights within no time.
Yes,
but
ma'am.
that
Yes,
will affect the performance. That will affect the performance. Some people will limit the water intake. Water plays a major role in our body. We can't limit water intake just before the competition. You can't cut down your carbohydrate intake, because that will affect your energy levels when you are performing. So the best way is if your weight category is somewhere 55, 55.5 is okay, but you make sure that the player is within that weight limit only. If any player is going beyond the weight limit, there could be two reasons. But he is in growing phase, so that is a high time to change his weight category. Sometimes coaches will think about the winning chances, and they will insist their players to be in this weight category only. You try to be in this weight category because weight chance will, winning chances will be more. But you have to see whether he is in growing phase or whether she is in growing phase. Weight changes are very common. Which weight category will be beneficial for her? All these things you have to check. If they are in growing phase, it is quite common to change the weight categories. You have to accept sometimes. And if it is because of overweight, you have to educate athlete that this is not suitable for you, because beyond this, it will be difficult for you to reduce the weight before the competition. Ask him to consult a nutritionist. There are scientific ways to reduce the body weight, not just before the competition. Maybe 1 month or 2 months before the competition only you have to plan based on his or her.
Ma'am, can you kindly suggest us some food that we should focus more during our weight cut?
So when you are planning to reduce your body weight, first thing you have to consume more amount of food which provides less amount of calories. Okay. Suppose when you're talking about salads will add more food to your plate, but they provide very less amount of calories.
Okay, ma'am. Okay, ma'am.
Fruits also. Fruits will increase. It will make you full, but it will give less calories.
What about
fiber rich foods also important. millets,
Okay, ma'am.
quinoa, all this,
Millet.
they add more fiber to your plate. So you feel full when you eat this amount of food. And calories also will be less compared. This kind of foods you
Okay,
do.
Okay, ma'am. What about vitamin C, lemon water, lime water, and all? Will it help us to cut down our weight?
See, lime water, it won't actually reduce your body weight, but when you are taking lime water, that will control your appetite to some extent. You won't have that food cravings again and again. So that will keep you full, stomach full, right? And so you will consume less amount of food actually.
Okay,
But you
ma'am.
can't
Okay,
see
thank you,
any
ma'am.
drastic change just by taking lime water.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Mansi is asking any specific good book where we can study this. There is no book as such. I can share the notes and PPT. Once this course gets over, I will share the reading material for all the topics along with the PPTs. Okay. I'll try to provide with Hindi and English, but I can't watch. Okay. I'll stop the session.
Thank you, ma'am.
Thank you so much.
Yes, ma'am.
Thank you so much, ma'am.
Thank you so much.
Thank you.